I'm Collin Wilkinson. I'm an assistant professor of glass science here at Alfred University, and I work in the Inamori School of Engineering, which is part of the New York State College of Ceramics. And so my research interests are really focused around how do we make materials more sustainably? If we think about kind of the materials that are all around us, like concrete, part of concrete is making cement and using cement. And cement makes up 8% of the anthropogenic carbon emissions out in the world. So between concrete and steel, we have a huge amount of carbon emissions just coming from raw materials. Glass is also part of the problem. Glass produces a lot of carbon emissions. So my group is really focused on how do we improve the process and how do we make greener glass. And that ranges everywhere from recycling to reuse to actually visiting factories and trying to improve their processes. The other half of my group is really working on the physics of processes, of glass processes. Specifically, if you imagine a big glass tank where if you've ever seen a glass blower, you have to actually melt the glass, right, to get a certain viscosity, a certain flow of the liquid. And we're really interested in how that viscosity connects to the actual physics of melting. Or reverse, there's also, as many of you have seen, you've seen the process of water turning into ice, and that's called crystallization. And most liquids will go through that process. So we're really interested in the reverse process as well as the melting process. Yeah, so if we think about the carbon cycle of the planet, a lot of carbon is actually just coming from us breathing, kind of biomass existing, right? Whether that be animals or humans or whatever that might be. But beyond that, we have something called anthropogenic, which means carbon emissions coming from our behavior, coming from human behavior, right? Genesis, origin, anthro-human, right? Anthropogenic. And so what we're finding is that this is the kind of carbon emissions that we need to manage climate change and to ensure a better future. I enjoy my work so much. My favorite part is interacting with the students, right? I have students everywhere from a first year college student up through a graduate student working in my lab. So every day I get to come in and I get to engage with a wide range of students working on a wide range of products to benefit the glass industry, to benefit you, to benefit the development of fundamental technology. I'm really excited every day to come in and get to work with these students, but most professors might answer that way. So let me give you another answer. My other favorite part is travel. I really love traveling, and because glass and ceramics are needed all over the world, all of us as faculty in glass and ceramics, all of us who are teaching glass and ceramics get to travel a lot. So in my career, I've got to work in Germany, I've got to work in Japan, I've got to work in Brazil, I've got to live a bunch of different places, and I've always had a great time and met great friends from all over the world through the work in glass and ceramics. Yeah, so as you can imagine, right, we have to make materials all over the world, right? Wherever we want to use materials, we want to make materials there, right? Consume locally. So in Japan, I got to stay with a close colleague of mine in Hokkaido, which is like a very northern island, where we actually worked on glasses for hydrogen fuel cell applications. So instead of batteries using lithium to shuttle back and forth, we were using hydrogen and pushing hydrogen through a material to generate electricity. In Brazil, I was just there for a short amount of time a few months ago, and we were there for a workshop. People from all over the world, students from all over the world, got to meet together and talk about the exciting research that's going on. We took 4 students from Alfred University, and we met students from France, China, everywhere at this institution. When I was in Germany, I was working on optics for what's called the Laser Interferometer Gravitational Observatory. I know, big name. But this is just a really big experiment to see if we can tell how black holes form waves in space and time. So when I was a student, when I was a freshman in college, I actually really struggled at first. It was really hard on me. But some faculty, some college professors got me involved in their lab. And I found so much meaning and purpose by acting in a lab, trying to solve new problems, problems that weren't pre-described, problems that there are known solutions for. I found that it allowed me to be really creative, and it gave me an outlet that if I was successful, I got to travel, which was always a dream of mine, and I got to meet people from all over the world. That has really pushed me to continue research my whole career. And beyond that, I really honestly believe that students who come here and work on ceramics and glass can have a positive impact all over the world. I was an undergraduate in a physics department, and I love physics. I still love physics. But over my time in Germany, I found that physics was a lot of really big collaborations working together to solve specific problems. And there's nothing wrong with that. That's amazing. It's an amazing time that we live in where people from all over the world get together to solve these big problems. But I ended up being more interested in not the big problems, but the small problems, the problems that influence people's lives day to day. And it turns out a lot of those solutions come from materials, come from, the glass on your phone, the glass on your TV, the ceramics that make up our energy centers, right? How do we use glass in the power grid? Because there's a lot of glass being used in the power grid for applications besides just screens, besides just the lens you're looking at me through. So another exciting aspect of my work is that my students get to interact a lot with big companies. A few weeks ago, we visited Sullivan Parks, which is Corning's research center, and Corning was very nice to host us. They were amazing hosts. And our students actually got to see their internal research process. Corning has always been very kind to us, but also many companies have. Schott USA, which is based in Pennsylvania, has also hosted us multiple times and have been very kind to donate supplies and help us here at Alfred. Next week, I'm going to Japan to go visit the Japanese Glass Center called AGC. Overall, one of the things that I love about Alfred is that we're so interconnected with companies from all over the world that our students get the best possible benefits. Yeah, so I think research is hard. Like, the goal of research is to do something that nobody else has done. And that, by its nature, is difficult. There's nothing that any of us can do to point you the right way, because often we, as the people who are helping you, don't know either. So I think if you're interested in research, you should be creative, you should be hardworking, and you should do it for a fun time. If you take it so seriously, it'll be hard, it'll be demoralizing. But if you're here to work your best and be creative and hang out with people that you enjoy who think in similar ways to you, I think research is a strong pathway for you. One of the most exciting things about research is the opportunity for entrepreneurship. After I got my PhD, I actually joined a startup company for 2 years. I ran a research and development department. I got multiple patents. We were able to build a factory. We sold millions of dollars of product. And so this was so exciting for me. And this is something that is at the heart of Alfred, one of the things that really attracted me here. People ranging from professors like Arun Varshnea and Bill LaCourse have started their own companies, but so have many students. One of my own students, Aidan LaCourse, started a company just selling very strong glass straws. And it was very successful, and he loved doing the work. The link between entrepreneurship and research is unbelievably close, and it offers a pathway for people who want to have a better future and to build something for the future. Research is hard. It's inevitably hard. But I'll tell you what, nothing will challenge you and make you grow as a person as trying to solve a problem with no known solution. No matter what field you're in, trying to solve something that's impossibly hard will get you to grow, We'll get you to look internally, and we'll challenge your creativity and your capabilities. It sounds scary to many people, and I understand that. But now is the time to try. Now is the time to try to see how you can challenge yourself and how to get yourself to grow. Because I promise you, if you start now and continue it for the rest of your life, it will only give you rewards.